Okay, so for number 1, after drawing the Lewis structure, so let's summarize this. After drawing the Lewis structure of CF4, we counted the number of bonding pairs, which is just the number of single bonds, so we have 4. And then for the number of lone pairs, we focus on the central atom only. So therefore, our central atom here is carbon, and since we don't have any remaining dots, because all the dots have bonded, so we have 0 lone pair. And then once we've identified the number of bonding pairs and lone pairs in our structure, then we can go ahead and look for the electron region geometry and molecular geometry based from the guide of the molecular shape. So this is our chart. Then we look for 4,0, and then after that, the first word that you see here is the electron region geometry, and the next one after that is the molecular geometry. So copy whatever words will be there when you get to see the equivalent values for that. I need to emphasize something also, like what if, Miss Narca, I get a 3,1 and it's a blank here? So this is blank because it means that everything here is tetrahedral. Okay? So everything here is tetrahedral because this belongs to 4 electron regions. So everything here in this group is 4 electron regions. So what do you mean by that? That means the total for the bonding and lone pairs will always be equal to 4. So if the electron regions for everything is 4, therefore the electron region geometry for all of them should be the same. So all of this will be tetrahedral. Similarly, if we have 3 electron regions, all of these here should be trigonal planar for the electron region geometry part. So if you see a blank, all you need to do is just refer to the word on top, and that is automatically the electron region geometry. Okay? Now, let's go to item number 4, our molecule number 4. Molecule number 2. We have HCN. Now, HCN, we have 3 different elements here. So, should this happen, that you have 3 elements in a molecule, all you need to do is follow the sequence of the elements according to the given. So, first element written is H. So, you write H first. Then the second is C. So, you write C second. And of course, N will be the third one. So, you put it as the third one. So, do not change anymore the order based on the given. So, after putting the correct order of the elements based on the sequence given, all we need to do is put the dots. So, 1 dot for hydrogen. And of course, we have 4 dots for your carbon. And then 5 dots for nitrogen. Please remember that you have to draw the dots carefully again, because you might be tempted to pair the dots according to what you feel like the most convenient way. But it's not about convenience, it's about accuracy. Okay? So when you draw the 4 dots of carbon, make sure that all 4 dots are single, and you should have an idea that because all the dots are single, you should expect that all those 4 single dots of carbon have to bond, not paired. Because the idea is, in a bonding process for covalent bond formation, all single dots have to bond. So if you have a leftover in your initial answer for carbon, that means you forgot the idea that all single dots have to bond. So since for carbon all the dots are single, you should expect that you should form lines for all those single bonds. In that case, I am showing you how that look like. So of course, 1 dot of carbon will bond to hydrogen. You have 3 remaining dots after that. However, for the nitrogen with 5 dots, 3 of those dots are single as well. So we have 3 single for carbon and a 3 single for nitrogen. Obviously, all those 3 dots will look for a partner, so you should be forming 3 lines. And 3 lines means we have a triple covalent bond. And when we fix this drawing and make this clean, this will look like this. So H, single bond C, and then we have a triple bond in which you can just clean it up and make all the 3 lines parallel and of equal length. so that our triple bond gets to be emphasized. Okay? And of course, you don't forget that there's one remaining lone pair in the nitrogen part. So please copy that as well. Okay? So this is now the final Lewis structure of our HCN molecule. Okay. The next part is the number of bonding pairs. Number of bonding pairs for HCN. I need you to remember step number 2. Step number 2 from the notes yesterday. There was an important note. There was an important note about double and triple bonds. And if you refer to your notes right now, it says double and triple bonds are counted as one bonding pair. This is in the case of molecular geometry only. So in the case of molecular geometry, because the shapes are dependent on the atoms, not on the number of lines, so therefore we count multiple bonds, either double or triple, as one bonding pair. Therefore, this triple bond right here is counted as one only, and because we have another single bond here, so this will have a total of how many? That will be a total of 2 electrons. I mean 2 bonding pairs. And then similarly, so let me put a note here. Triple bond is counted as one bonding pair. Okay? Okay. So now let's proceed. Number of lone pairs. Number of lone pairs have to focus on the central atom. So among the 3 elements, of course, our central atom will be carbon in here. You don't see any remaining dots. Therefore, that's a 2 and a 0. So 0 lone pair right there. Now it's time for us to refer to our molecular geometry chart and look for 2, 0. And it's easy to locate it because it's the first one indicated in the chart. So we have 2, 0 here, and the electron region geometry is linear, as well as the molecular geometry is also linear. So all you need to do is write the word linear there. Okay? Show you what I showed you for NH4 a while ago. Look at the NH4 plus. Okay. Now, for those of you who forgot the idea, if you're given a charge, remember that there is either an additional electron or an added electron. So if you see a plus sign here, a plus sign for NH4 plus, it means that you have 1 electron removed. You have 1 electron removed from the structure itself. So if you're going to think it this way, I have N and 4 hydrogens. So obviously my N will be in the middle and I have 4 hydrogens surrounding it. I have 1 dot for every hydrogen, but nitrogen should have 5 initially based on the group number on the periodic table. This should have 5. However, I look at the charge and it says that I have to remove 1 electron from there. Obviously, if you will be asked the question, where can I remove that electron? You cannot remove an electron from hydrogen. Because if you remove an electron from hydrogen, you can't bond anymore. Hydrogen cannot share an electron anymore. So obviously, if you look at the 5 electrons of nitrogen, 5, but there are 4 hydrogen that it can bond. 5 minus 4, I'm left with 1 electron. That 1 electron cannot be alone. So therefore, I can answer the question, where can I remove that 1 electron from the charge? That 1 electron will be removed from the nitrogen in the central atom. So 5 minus 1, I will be left with 4 dots already. And that is exactly the number of hydrogen atoms as well that will be bonded to it. So 4 and a 4, we get 4 single bonds. So you should not write any leftover dot for the nitrogen here because of the concept of 1 electron removed. And that is due to the plus charge of your ion. Okay? And remember, plus meaning you subtract. If it's a minus later on, that should be an added electron. Okay? But in this case, it's removed, so you subtract it. And so, when you count the number of bonding pairs, of course, that's 4 single bonds, so you get 4. And then, do we have any lone pair again for the central atom? There's none, of course, so that's 0. You see 4, 0, and the one on top is also 4, 0. Therefore, you don't have to look at your chart anymore. Just copy the 4, 0 on top. They're both tetrahedral, so just write tetrahedral there, because it will never change. If the two numbers are the same, then they get to have the same electron region geometry and molecular geometry. So these are the complete answers for the first 3 given. So we have 2 molecules and an ion. So that ends my short review and discussion